Hello, everyone. So, we will now be talking all about the projectile motion, which is basically a continuation of our discussion. So, please excuse me if the camera is found slightly below my face. Kay kapoy kasi pangita og area kung asa dapit. So let's have a recap muna. So we discussed last time that the projectile motion is basically a motion or a movement in two-dimensional. So it involves the x and the y component. So mura siya parabolic, no? Ang iyahang movement actually. Now in this case, we call the path as a trajectory. That's what we call that, no? Trajectory ang atong tawag niya. Now we have examples here. Meron tayong mga sports like soccer, tapos volleyball, lawn tennis, tapos we also have magdula ka og kanang kuano, jollen. Tapos naapod tay when you will be thrown by something like this with sa ba labayon ka. And you also have here a human cannon, no? Sa human cannon ball pala. And you also have here ang pinakasikat nga dula sa una, which is ang Angry Birds. Now, in this case, we call this as a trajectory kasi nga it is a combination or the movement that involves the x and the y component. My example last time is when this cannonball is released without the presence of the gravity, diretso ra gyud siya, no? Straight ra gyud siya. But because of the presence of the gravity, ginabira siya downwards, no? Kuan siya pull downwards. That is why it is curved like this. And we also have here the our discussion in the previous session where in a full projectile, the velocity involved should be taken in terms of the x and the y components. So basically, it means that if you have the value of the initial velocity, you have to solve for the x and the y component. In this case, the red arrow is your x component of the initial velocity. And when you try to check it, from the moment the ball was released up to the very last point, no, nga na siya sa ground, dili siya mag-change. So it simply means that the value of the x component of the initial velocity will become constant or is constant from the very first or from the first movement until the last one. While on the other hand, the y component, which is in green arrow, siya lang ang mag-otro-otro. As the ball moves up, it slows down. It will have a temporarily nga zero ang iyahang velocity, but after that it will fall back to the earth, regaining the same velocity na pod in the y-axis. So it's the velocity in the y-axis that is changing. And also the um, acceleration due to gravity is also the same. Okay, I would like you to remember that. Now this is a representation of a simplified one kanang wala naglihok, no, but I already emphasized last time that we are using actually instead of vina, pero same ra na sila buot pasabot actually, same ra gyud na sila pasabot. Okay, now in this case we have here the representation of the initial and the the x and the y components of the initial velocity. So how are you going to solve that? So you simply need to check it in the sense that you are going to solve for the x and the y components first before everything else. So in this case, instead of v naught, we are using the v sub I ha as our symbols. No? You have the x component, so v sub ix. So that means this is the x component of the initial velocity is equal to v sub I, the initial velocity, cosine theta initial. So, let's granting that the initial velocity is 20 meters per second, so we simply substitute 20 meters per second. Tapos, you have there cosine theta, assuming that the angle is 50. No, let's try 50. So that's 50 degrees. So you simply multiply this 50 or cosine 50 first, then you multiply the answer by 20. That should be the x component of this initial velocity. Kana kanang initial velocity. Okay? But I want you to use your calculator para kabalupod mo and you can practice answering, no? So please continue answering this or solving this one. So let's proceed to the y component. So we have v sub iy, which is the y component of the initial velocity. is equal to the v sub I sine theta sub I. So if we're going to substitute, the initial velocity is 20 meters per second multiplied by sine 50 degrees. So you simply multiply the sine 50 muna, hit equals, and then you multiply the answer by 20 meters per second. And that should be the value of your y component for the initial velocity. So please continue answering, no? Kaya para ma-practice po mo on sa pag-answer. Okay? Now, in this case, you also have here the different useful formulas. But again, starting from our discussion with the x and the y components, movement in the x, movement in the y, or motion in the x component and motion in the y axis, mga free fall, we are using the same formula. But I would like to emphasize that instead of using the knot, we are using the initial v sub I and the v sub f. But the addition here, yung nasa baba, ito, is simply a substitution of this 3.9. So your formula 3.12 is simply a substitution of your formula 3.9. So unsay nahitabo? Granting that there is no initial x value there, and then that your initial velocity v sub x is basically v sub I, v sub I cosine. V sub I cosine theta. So you simply substitute this in the V sub ix, or in this case, nakita ninyo sa screen, V naught x. But again, we're using different symbols pero same ra na sila og pasabot. Same ra na sila concept. So you simply substitute. That is why if you will substitute that in formula 3.9, it will now become formula 3.12. So same ra na sila nga mga formula actually. Kanang 3.12 is similar or related to 3.9. Your formula 3.13 is similar to your formula 3.11. Your formula 3.14 is similar with your formula 3.8, and your formula 3.15 is similar with your formula 3.10. So they are all similar with each other. It's just that we substitute the x and the y components na formula, which is the cosine and the sine thetas. Okay? So if we're going to check this one, this is a half projectile and another half projectile. Pero technically speaking, there is really no separation between or difference between a half and a full projectile. We technically call them projectile motion. Kasi nga, na hog lang siya, or we simply term this as half projectile kasi half siya sa parabolic like this, sa tong curve, sa trajectory, kay half man siya. Pero technically, they're both um, projectile motion. Same ra na siya actually, no? So we have here an example para mas masabta nato. Now, the very first thing that you're going to do is really to read the problem, no? So, in a given picture below, Alice throws the ball to the positive x direction with an initial velocity of 10 meters per second. The time elapsed during the motion is 5 seconds. Calculate the height that the object is thrown and the velocity or the y component of the velocity after it hits the ground. So, after you read the problem, na ay ano nato din na drawing. So since na may drawing nato diri sa baba, okay na ta. No, nanay time tapos na ay height. So the very first thing that you're going to do is really to solve for the and the x and y components of your initial velocity. So let's try to solve it. So in this case, we have the v sub ix is equal to v sub I cosine theta sub I. Now, in this case, if we substitute, the initial velocity is 10 meters per second. You multiply that by cosine theta. So in this case, if we try to check, no, let me try to zoom it in. Yeah, if we try to zoom it in, technically speaking, the moment nga gilabog ni kasama ni siya si Alice, the moment that Alice throws the ball and the very first part of the trajectory, there is no angle there. So the angle is 0. So in this case, we have cosine 0 degrees. So if we try to solve it, 10 meters per second multiplied by cosine 0 is 1. So we simply multiply this by 1. So in this case, the initial velocity or the x component in the initial the x component of the initial velocity is basically 10 meters per second. So let's proceed to the y. V sub iy is equal to V sub I sine theta sub I. So in this case, we have still 10 meters per second multiplied by sine 0 degrees. So the sine 0 degrees is basically 0. Sine 0 is 0. So in this case, the value of the V sub iy is 0 meters per second. So we do not have the value for the y component of the initial velocity.